Okay. For some reason, Epic Games Launcher is running. It needs not to do that. Anyway, what did you do? Okay, so then mandatory attendance thing. I think everyone did this. Um, Adding concurrency for fun and profit is an event that I will be holding sometime in there. It looks like the most popular time is actually Monday, the 24th, right now, but I will decide on the time uh, a bit later, but like within the next few days at most. So really, like, please get it in today if you want. If you want to indicate your availability. But yeah, so what is this event about? This will be some Python code showing how concurrency can make algorithms a little bit nicer to write and read and maintain. Specifically, ideally, focusing on some things that are really tricky with binary trees if you don't use concurrency. And the way that they're taught here is without the concurrency, but are really easy with binary trees if you do use concurrency. In my opinion. So if you're interested in that, please indicate your availability there. And it'll be announced on the Lug Discord on the ACM Discord, like everything. This is an ACM event. My bad. So, Ethan, did you hear that?
Yes.
Okay, yeah. And of course, these slides will be posted. So, Okay. So it's the Lugrest Reading Group. That's the wrong crab. That's the crab from Mario Kart. But anyway, I've been enjoying Mario Kart. There's the crab from Mario Kart. Anyway, pop and drop. Oh, and also, if you didn't see the thing in the Discord, there is now a link that you can go to that just takes you directly to whatever we're talking about in the next meeting. So I think now it'll take us to what we're talking about in this meeting, but as of the end of this meeting, as of 4:30, it will take us to the other thing. And that link is, if I can remember it, though I'd recommend not relying on remembering it if you want to use it, it is rust-reading- it's not that. rust-reading-group.samuel-skeen.workers/dev/redirect. Okay, pop. That's hilarious. That is a Firefox bug. That is not what I'm looking at. There we go. The URL bar was still my thing. That's hilarious that that's a Firefox bug. Anyway. Okay. So, if I recall correctly, let's make this a little bigger. We have an issue, but I don't think it is with... Yeah, okay, it's just in main.rs. So I'm actually going to comment this out as opposed to just delete it, because, I don't know, someone might want to look at it. That is really silly. Okay. Now we can't compile it for some reason. And the reason is because... No? That doesn't make any sense. Mismatched types. Oh, right. Because we haven't implemented pop. Yeah, that'll do it. So that's what we're trying to do. We're trying to implement pop. So I'm going to actually bring this up. Okay. So yeah, so last time we talked about how we want pop to return an option because maybe the list is empty, so maybe there is no element to return. She likes to talk about pointy bits to mean angle brackets, which I think is cute. So yeah, you can have an option of anything. So how do we figure out if it's empty or has more? Yes, so we want to look at our head of the list. Let me know if I should make this bigger at all. And our head actually, so we're going to match on it. I don't think I've shown that before, but it's a lot like a switch statement or a match statement in F sharp. You match it against different variants of the enum in this case, because it's an enum, and the compiler will helpfully tell you, exactly what is going wrong. So we can just say in the empty case, what do you think we should do if our head is empty? Just first guess.
Nothing. Probably either nothing or print an error statement.
Hopefully nothing.
Okay, we should do nothing to the list, right? We can't pop from that.
Yeah.
But why do we return option?
So
In case it's not empty?
In case it is empty, right?
Oh, well.
But in both cases, right? We want to handle both cases, yeah. So
you have none.
yes. So none is the variant of option that represents there wasn't anything, right? And what that means is what we want to do here is we could have written this so that it errors, but I actually think the way that we're writing it already would indicate, that there's a problem if we returned none, right? So we don't need to error, we just need to return none, reflecting that there was nothing. So we can do that with return none. Actually, we don't, so for talking about this link, we had to do link : empty. But for talking about this option, we just have to return none, which is funny. I think you can do this, but they have made it so that you don't have to. That's very silly of me. Okay. Yeah, so we can do that. But, of course, we don't have another element to the match statement. This is unlike match statements in F sharp. This is unlike switch statements in C. It is a compile time error if you don't cover all of the cases. You could have a catch-all. We might go over that later, but for now we actually do want to do something meaningful in each of these. So we'll say link of more, and what's inside of more? It's a box of node. Okay, so I guess I'll say next. What?
No, you're already typing it. So.
Oh, okay. Well, what did you want to call it actually?
No, I don't want to call it something.
Okay.
I was saying what it would return. So
Mm.
it's kind of obvious that it's a pop and you have a list. You return the head of the list or the number of the list.
Yes. Yes, actually, this is, I guess, no, you're right. This is the first. I thought it was the next, but in this case, it's the first. So honestly, I should be able to, okay, well, she's gotten this far at least. Though she puts like braces around the return none, which is fine. This function's body doesn't return. Okay, well, yeah, let's see what error message we get, because our function's body does return, but I bet it'll have a similar error. That's funny. I didn't say return here, right, but our function's body does return in at least one place here, right? So we definitely have an error. We need to return in all the places. I guess let's start with, okay. If I delete this, then I think I have a syntactic error. So let's see if I have this. Okay, it doesn't have exactly the same error, but it is like the same message. But it's the same idea. They're saying, yeah, sorry. Yeah, see ya. They're saying we found this empty tuple type. That's what open paren, closed paren means. And like I didn't actually return anything, so you might be wondering like how did it invent this? Well, this is just the default thing that empty blocks evaluate to, the default thing that they return. So it's exactly equivalent to if we did this. So the empty tuple, who here has not heard of tuples? Everyone's heard of tuples. Okay. Yeah, the empty tuple is just how Rust writes the notion of there is no meaningful value here because an empty tuple holds no information at all. So it's basically their equivalent of void. you don't really need to think about it too much here, but because nothing actually returns it, but that's what the error message is talking about. So definitely I want to return none, but okay, yeah, we could return none. In this case, it's probably better to return unimplemented. Okay, yeah, so she also, sometimes the compiler errors can get so annoying because Rust is so insistent that you return things of the right type, that it is useful to temporarily say that this method is unimplemented. And this actually does return something. So I don't think I went over this, but Rust functions, or methods, whatever, Rust functions, both of them, both methods and functions, they, by default, return the last expression, just like in F#. So this is exactly equivalent to this. And this isn't, I think. Let's see what happens here. No, maybe that's fine. Oh, right, no. So unimplemented. So this is a bad example, but it isn't in the general case, but this works. But the thing is, unimplemented causes your code to panic. So it does sort of evaluate to a value, but really it just tells the compiler, that this method, this function isn't actually going to continue running after this point. It's going to panic, so anything is fine after this point. We do still have to fix our other errors, but we'll get to those. Yes, she talks about how that means that it's a diverging function. It doesn't work at all like a mathematical function. I wish our math guy were here, because I think this is written more for him. No, Andrew, the guy who's been, I think his name's Andrew. He's been here occasionally, but yeah, see you. Yeah.
What I want to know is,
So, yeah.
as a former math guy, what's a converging function?
I don't know.
Because you have convergence and divergence, so I'm wondering. if
Let's
that's
just
a-
see. This is okay. Diverging function just takes you to a Rust thing, which is useful about the type of unimplemented, but I don't think that's the most important thing here.
A diverging function is a function that does not approach a finite limit.
That is the opposite. That
So
is
it is
non.
like-
Yeah,
Literally
yeah.
does
Diverging
X approaches-
function or diverging series?
Function.
Interesting.
So it's like limit
Okay.
as x approaches infinity. It's not.
Yeah, at a certain
Okay.
point, it doesn't, right.
Right. So this is a different usage of the term, and that's kind of unfortunate.
Yeah.
This means this function doesn't actually evaluate to anything. You start evaluating it and then you
Sorta
leave. No,
But
well,
that's sort of true. If
of the-
I see how it's originated.
yeah,
but
of the
not
se-
really
that's true of the
the
series,
same
but
thing.
for any given point along the series, you could calculate
Well,
it.
in a function that say that goes towards infinity at the point, there isn't actually a value.
Oh, I see.
So I think.
At that
does-
point,
yeah,
okay.
yeah.
It
Like 1
makes
over
some
x
sense.
is not defined at 0.
Diverging functions
Right.
never return them not using an
And it
Oh, okay.
diverges
Then
it.
This is the
I
rough
never.
draft.
That's
Oh,
what
okay. That's the
diverges
yeah.
means,
Anyway, so now we're having an issue. Before we even really try to do something, I guess I went further because we should return none in this case, but we're having an issue. Cannot move out of self.head as enum variant more, which is behind a mutable reference. So I spoke that in the wrong cadence, but can't move out of self.head as enum variant more, which means that the place where we're trying to move out of self.head is where we match on more. And that sort of makes sense because, that makes sense in one sense. Like I've been saying that by default, you can't move out of things that are behind references. And this is still behind a reference, mutable reference, but a reference still. We don't fully own the list. It needs to remain intact. But I guess the more intuitive thing is there's something about this variable first that means that we can't move out of it. What is it about this variable? Like, if this were an integer, this code would work. What is it about this that we can't move out of? Or we can't just copy it, we have to move it, I guess is the point. I'll reveal more of the code.
you ask the question again?
Yeah. What is it about the variable first here that means that we have to move it? We can't just copy it.
Is it because it's a box? And,
Yes. So what is it about boxes?
So when you pass box in a function, you
Yeah.
have to remove it. And it's because like box, if you have to copy a box, it does a deep copy, and you don't want a deep copy, and that's why you just basically move it.
Yeah, it doesn't
Yeah.
it doesn't do the deep copy by default. The idea of box is that it just owns that area, so we can't have two owners of that same
Of the
area.
same area,
Yeah,
yes.
the deep copy would be necessary to split them, but
To
yeah.
yeah, so that we don't have multiple
Yes.
free statements or something like that.
Yes, we don't end up double freeing it. Okay. So we have that problem, and let's see, is it telling us? It is not really telling us what to do here.
Moving, though, I mean, all
Yeah.
we're saying is that we're gonna return empty.
Right, so the problem is,
Yeah.
at this point, we do have this first variable. We could do things with it in this.
Oh,
First,
because
You know?
it's local inside of this block, right?
What is the problem?
It's not
with
so much
returning
that it's-
first, though?
So the problem is that the problem with returning first itself,
Is you could return it or something, okay.
the problem is, well, the
It's
most
not what
obvious,
we are doing, it's what we could do. Is that what-
yes,
Okay,
kind of.
okay.
Basically, yeah. Like,
'cause that's what
because
confused
you
me.
can think about this function as like doing nothing
Yeah.
with first at all, but we have first here. So this function owns first. And that means that when this function ends, first is freed, which means we fucked with the list. Like that's the problem. The issue isn't actually down here, or that the compiler error isn't down here. You are interrupting me. The compiler error isn't down here, but that is where the actual problem in the like execution would happen. It would be down here where we free it prematurely. And yeah, why can't we just return it? I think we'll get to that, but the easiest answer is the types don't actually quite match up. Yeah.
The box, yeah.
Okay. Yeah. So let's see if the compiler got worse, because I really like the error message that she's seeing. Oh, no, the compiler didn't get worse. That's good. So we're seeing the same error, but then it actually tells us what to do. It also tells us the thing that is special in Rust lingo about box that means that we can't just copy it is because it doesn't implement the copy trait. I don't know when we'll get to that, but I think we will. And things by default don't implement the copy trait, but really most like normal values like integers do. Boxes definitely don't, but for the reasons we talked about. Okay, it literally tells us consider borrowing here. That means consider matching not on the head itself, but on a reference to the head, which allows us to look but not touch. And that means that what we actually get here is not a box, we get a reference to a box because we were matching on a reference. And matching doesn't take a reference by itself. So this means we're fine. We have a reference to the box, which is a pointer to a pointer, which is awkward, but we have a pointer to a pointer, and then that pointer disappears, and we're fine. When this function ends, the list is untouched. Okay, Arrestus Helm added us. It's telling us what to do. Let's try it. And then it's compiling. Okay. In the empty case, we need to return none, like we already did. In the more case, we need to return some of the integer that's in first, and we need to change the head of the list. Let's try to do basically that. Okay. So, yeah, we can just sort of say that we have some variable. Does she put that? Okay, she puts that at the top. She says, we will have this variable result, and we're going to make this result equal sum of first. I'm not sure if that's exactly what she does, but then we also, what's the one thing we need to do here other than decide what we're going to return? I'll fill that in. So we are going to return result, right? But there's something more that we need to do right here, because this list function is not just trying to get, this pop function isn't just trying to get the first, it's trying to return the first, right? Sorry, it's trying to change the list, right?
To have no first.
Okay. Yes, we're trying to Like, so if our list were empty, we would want to end up having no head at all. But if our list had multiple things, what would we actually want to do?
So we don't want the top element of the list, or like the head of the
Right.
list, and to change the head to the second element.
Yes. So let's say the self.head should equal first, which is a box of nodes. So, first dot next. Nodes have a next. So yeah, even though this first is a reference, first is a reference to a box of a node, but this dot handles all the dereferencing that's necessary to get us the actual next on that box. So we have, I think, a problem here. We have a problem because result is an option of a reference to a box to a node. So that's not right? We need to return the element. And now we have a problem because we can't move out of first.next, which is behind a shared reference. That's exactly the issue that I think, is basically the same issue that we had before, except now the issue is with link head desk. We're trying to move out of node when all we have is a shared reference to it, right? Which is important. We got that shared reference here, even though we have a mutable reference to the whole list. So now she describes the whole logic. So we do want to get the head of the list by value. Like in the end, I said the problem was we would fuck up the list by having this result, but we actually want to free that box in the end, because it is the box of the first, which will no longer be on the list, and we're not returning a box, we're just returning the integer. So we will end up freeing it. The problem was we couldn't do that without changing the list. So now we are trying to change the list, and I think this doesn't help for the same reason that we needed mem replace before. Like, we are moving out of it. We are messing with the list. We are not allowed to do that even for a second, even if we repair it later. So, yes, the only way we can move stuff is to replace it. Look like we'll be doing the empty dance again, where we replace the head with empty. Which again, this bit, we actually are modifying the head. So we're using the mutable reference. But we're not just moving out of it. Replace handles this for us. What do we want to do? We want to replace it with empty, right?
I love how she calls it the empty dance.
The empty dance, yeah. Because it really is sort of a dance. It's awkward. Then I guess that... Oh, well. We need to call it by its full government name again. Does that work? That works. No warnings! We made this... Okay. Yeah, so now she's talking about how functions return their last thing. I think this is a good expression of it that I probably didn't get to all the way, but now she talks about the empty tuple. Right, because if your block ends with a statement with a semicolon, we actually do end up with an error, and the error is that it found the empty tuple, which is also known as the unit type, because this statement did evaluate to an expression, or this block did evaluate to an expression. The whole function did evaluate to an expression, even though this is a thing that ends in a semicolon is a statement. So yeah, rest is pretty expression-based is the term for language nerds. Almost everything is an expression, and even stuff that doesn't logically totally make sense. But I guess you can imagine, like, it's safe to think of statements as just giving you no value if you don't try to extract their value. Here, though, we're not using a statement, we're just using a value, result. So I think, right, she created, I'm not entirely sure if I agree with all of her reasoning here, but she created this variable, I guess, to hide the fact that this code is really quite, or that this feature really means we can avoid this return, right? We could have done this, and then it really makes sense to have this variable. But otherwise, we could just have the match statement evaluate to the thing that we want to return. So we don't even have to have this return here. We can just say the match statement evaluates to none. And then we can say this match statement evaluates to, well, we have to move this around, but it evaluates to this, maybe? Now we have a mismatch type because this has a semicolon. So it evaluates, this block evaluates to that. And now we have an issue. This is actually an error, not a warning, because we didn't give it any type information. It was figuring that out quite magically on its own when we were assigning to it, but we don't even need that variable, so it's not really an error. And this works just as well. It's a little bit maybe weirder to look at, but I think it's nicer. We don't, result was a meaningless name anyway.
I like this better.
Okay, awesome.
Also,
Yeah.
why did it have a problem with the semicolon and some?
Right. It's because this doesn't,
That is weird, because
so it's weird from a very practical standpoint that I will totally agree with, which is this means that our semicolons matter. In most languages, you either need them or you don't need them.
Yeah.
And they're really small and fiddly, and you can forget one, and it changes the meaning of your code. Sometimes, here it's kind of safe, I guess. It changes the meaning of our code from valid to compiler error. But sometimes they can actually both be valid, which is pretty awful, which means you end up doing the wrong thing. But the actual reason is because with the semicolon, this is equivalent to the C statement, which I think it is a valid statement in C, like this. I couldn't do foo of 5.
Oh.
And I couldn't do that for syntactic reasons in C. You can't have statements and expressions in C. But in Rust, you actually can have statements and expressions if you put them in a block. Blocks sort of bridge that gap. Blocks are expressions, but they contain statements. So at this point, this is syntactically valid Rust. But foo isn't actually getting any value because the value of this block is determined by the statements within it. And this statement is just a normal statement.
Yeah, it's not a value. Yeah.
It's not a value. So then we'd need to do this. And I mean, in this actual case, we wouldn't want the block anyway. But if we were trying to compute something, maybe we would have the block. We just need to leave off the semicolon at the end so that the last thing in the block isn't a statement. It's an expression. So the whole block evaluates to that. And this is identical to that. Do you see the connection? Where here we want this block to evaluate to this, which means that the whole match statement evaluates to this in that case.
Okay, I see where you're coming from.
Yeah, but it is odd. It's one of my least favorite things about Rust that we end up with load-bearing semicolons. I like the phrase load-bearing because I read a taxonomy of a bunch of bugs at one point. Someone was mostly humorous purposes, trying to come up with the different kinds of bugs that they found. One of them was Heisenbug, which is a bug that appears to disappear when observed. A Heisenberg principle style thing, Schrodinger's cat.
Okay.
And one particular kind of a Heisenbug was a load-bearing print statement. A print statement that logically shouldn't affect anything, but if you remove it, then your code starts working or stops working. And it's you're using this print statement to debug, and it's god-awful because it appears, that it disappears. I like that terminology. Okay. So I feel like we've gotten pretty far because I think this pop works. Yeah, so now she likes it, and then yeah, finished. We do have warnings, but that's because we did this, which let's just stop doing that. No warnings. Testing. Interesting. So she does testing first. Is Dan not gone for good, right?
No, he has a jacket.
Okay, yeah.
He's gonna come back. At least for the jacket.
Yes. We can go through testing really quickly. Who likes testing?
No one.
No one. I do think Rust makes it. Do you like testing? No. I do think Rust makes testing kind of nice just by having the very basics built into, I guess, to the language. Rust and Cargo support testing as okay, this isn't very clear because Rust and Cargo are intentionally different things, right? Like you can use Rust without Cargo. But for this case, I think you need both for testing. Anyway, it's like pretty simple. I guess the only trick here is all of our files have been modules so far, which is just a way to organize our code. And it's the only boundary on which like being public or not matters. You can also define modules without creating a new file, which is quite nice if you literally just want your testing code to be like a barnacle on the side of your code that you're actually testing, and for other purposes too, maybe. But here that means, we're not exposing anything about this module outside of first.rs. So it can only, it can look at other things that are public, but it's only going to end up looking at first.rs because it's just testing that, and it's just kind of nice. Then we have a macro test that says this thing will be a function used to test. And let's not name it test. Let's, right, we have to use the fun keyword, or fn keyword. Basics is a better name, and that's fine, but it just doesn't do anything. Right, then you use cargo test to actually test it, and it's great. Our test passes, even though it doesn't do anything. And then this is just, maybe I will let you just sort of look at this and see if you have any immediate questions. I think these are well-written tests.
Yeah, looks like normal testing.
Yeah. I think I like her, I like this comment a lot, check exhaustion, because that's not an obvious name for it, and I think that's exactly what you should call the case where the list actually ran out of things. And I pasted it, but my editor is set up, and you can set up your editor to automatically format it when you save, which I'm going to do with the Vim shortcut, which is nice. But it doesn't know what list is, which is just more module shenanigans. That's because we need to let this module know that it can, we need to basically import the thing from the outer module into this. Like this module is effectively in a different file as far as REST is concerned after it parsed out the module statement. So we can...
Modules in general or just test?
Modules in general.
Okay.
If you declare a module with this syntax with the braces, then it's like effectively a different file.
Okay.
That makes sense.
Yeah, it makes enough sense, I think. I guess we didn't have to say anything. Okay, yeah.
Do you have a global variables amongst the modules?
A variable that all the modules can access? Yeah, it would just be a public global variable.
Okay.
We haven't gone over how to do global variables at all, but
Yeah.
But you would have to import it into every module where you wanted to use it, or refer to it by its full name. Like in this case, I think it would be the full name of list. We're just going over testing, which apparently you do in this book before drop. So hopefully we'll get to drop. But you could also refer to it by its full name here, without importing it. Right? It's not like the importing is just okay. Interesting. We can't do that. Maybe we have to do crate : crate is like the root of all this. So crate is what this whole thing is. So it's like a path, like crate, which you can think of as just a slash, and then go into first, and then the list inside that. But so we could definitely have done use crate : first : list, and then just change this to use list. Interesting. What? It is used. I use it here. Okay, if this is a really low-hanging fruit bug or something, that's hilarious. Cargo build. Because if I remove this, then it doesn't work. Oops. Okay, well, I'm glad I have a video of this for two reasons, because I want to file that bug. That's hilarious. This is used. Anyway, I'm more excited about that than anyone else, which is good. Bugs are not that interesting. But this super is kind of interesting. it is just a shorthand for the module that this module is inside. And the module that this module is inside is first. So you can think of it sort of like the super keyword in object-oriented languages. Wait.
Yes.
Oh no, this isn't a bug. Okay, I'm glad we get to learn something. This isn't a bug because when deciding whether we didn't use this, it's just thinking about the code that would actually be compiled when you compile for production, which would not include tests. When you compile the actual code of your project, of your library or whatever. So what we have to do, let me think. Right. So effectively, when we're just doing cargo build or cargo run, it shows us this because effectively it sees this module as just being this. Because that function wasn't,
It's just a test.
that function disappeared when it was looking at it for that purpose. So the way we fix this is we make it actually only see this module when we're building tests, which is we say it's dependent on the configuration test, which is something supported by Rust. And now we're all happy. But I don't get to file a bug, so I'm sad. I'm really glad that there's no bug there. Okay, drop. Dan, drop.
Oh, yeah.
Do we need to worry about cleaning up our list? Technically, no, not at all. Also, did I test it? Let's just make sense. Make sure. Yay! Our test that actually does something works too. Technically, no, not at all. Like C++, Rust uses destructors to automatically clean up resources when they're done with. Resources, not just memory, but in this case, just memory. A type has a destructor, which means it has special code that run. Okay, yeah, this is sort of. Yeah, so in C++, if you have a type that has a vector in it, you don't need to write a destructor to free that vector because the vector's destructor does it. So your type's destructor, or the code that runs when your type exits scope, includes the destructors of its members, even if you didn't have a destructor. That's the same way Rust thinks of it, basically. I just have to work through it in my head again. We say that the type has a destructor if it implements a trait called drop. We don't implement that trait, but there is still code that runs when we when we reach the end of this basics function and we no longer have that list. It still cleans up the nodes because those are boxes and those have destructors. Traits are Rust's fancy term for interfaces. The drop trait has the following interface. So yeah, to actually implement your destructor, you implement the drop trait, which is like an interface, and you implement this function, which takes a mutable reference to self, which I guess is a little funny because self is not going to exist anymore, but so it's we only get to modify it even though it's not going to exist. You might think it should take self by ownership, but I think this avoids an issue where, if drop, this function, ended up owning self, like it just took self, then at the end of drop, self would exit scope, which means that at the end of drop, self would be destroyed, which means because self has a destructor, we would call drop at the end of drop, which would not be good, right? This means that drop never owns it, so drop never cleans it up. Drop never calls itself just by virtue of ending. Yeah. So drop just is the last thing to visit it, which I think makes last thing to look at it and change it, which I think makes more sense. I think that clicked maybe, but does anyone have questions about that? Okay. Yeah, I'll give you a second to clean up your affairs. So you don't need to implement it if all you'd want to do is call their destructors because that'll be called for you. all that's handled automatically for us. Like our code does not have a memory leak. I think if we ran it through Valgrind, it would say we had a memory leak, but that's because Rust is weird and does things that Valgrind thinks are memory leaks, but like aren't a problem. But it's gonna be bad. This is interesting. It's gonna be bad because the way it does the normal dropping is gonna be recursive. Recursive code can blow the stack. The reason why we put our list on the heap is because it's potentially very big. And, if we then grow our stack to the size of the list at the time of its destruction, we're kind of losing the benefit of, or part of the benefit of having this list on the heap, having this list be able to be used. So, yeah, effectively the code that they generated for what happens when you drop. I don't love the fact that she's implementing drop here because that's not at all what the compiler does. But this is the code that runs when you drop it, and the way we do that is we implement drop. Unfortunately, okay, wait, no. She is, okay, no, let's see. Implementing drop, I ran ahead. Let's try to write what the compiler has to do by manually implementing drop for the list as our compiler would. So if we were implementing drop, we would say we need to drop the head. Okay, this will be done for us, right? But this is tail recursive. Does anyone not remember what tail recursive is? It is a tricky concept. Do you remember? Sure, it's...
Have you taken 341?
Yeah.
Yeah.
Honestly.
No, it's fair. This is tricky. Do you want to try to explain it, or shall I explain it?
You can go ahead and explain it.
Okay. So, you know what recursive is, right? Calls itself eventually. This isn't directly calling itself. It's calling the one on the link, but it'll end up calling itself. Tail recursive is when that call, that recursive call, is the last thing that happens. The reason this is important is that it means that the compiler can make it so that that call actually reuses this stack frame. If that's the last thing that happens, we don't need to remember anything else about our current context. So we don't actually need to grow the stack. We just reuse our current stack frame, which means that the code that ends up happening, like if you have a tail recursive call at the end of a function, that machine code that's generated is, I think, equivalent in basically every way to an iteration, to just a loop that does this thing over and over again, because it's not growing the stack. So this is tail recursive. It's the last thing drop is doing. This is also tail recursive. Dropping our node is the last thing we're doing. This is the problem. Actually dropping the box itself, which is, again, written for us, is not tail recursive because we need to drop whatever's in the box in case it has destructors. It doesn't for us. It's just an integer. But we would need to do that first. And then deallocate the pointer, the thing that the box is responsible for. Let me think if there actually is a problem. Is there actually a problem with this if we just have integers? Because the integers don't really have a drop function. Let me think about this. So let's think. This is tail recursive. This doesn't really involve any recursion itself at all. This is just like the head of the list. This does. We need to drop the thing inside the link. That is the last thing we do, which means theoretically we could drop this link and then drop the next link. I'm not sure. Maybe she'll explain this, or maybe not. think it's really funny that she does this when our list is still just a list of integers. It certainly matters when we have a list of things that might be more complicated, right? But I think the important thing is, okay, we can't drop the contents of the box after deallocating, right? Because after we've deallocated, it's not there anymore. We can't call something on it. So we have to manually write an iterative drop for list that hoists nodes out of their boxes, that drops the node one at a time. I think the intuition for this is that our code will end up like dropping it in the opposite order. It'll drop head first, whereas the default generated code will drop the last node first. It'll like look at the first node and be like, can I drop this? And then it'll look at the next node, and then it'll look at the right. Wait, I am being very silly. It has nothing to do with whether integers implement drop. I'm sorry. It has nothing to do with whether our integers need freeing. The thing that we're calling drop on here in the not Taylor recursive way is the node, which definitely doesn't implement copy, which definitely implements drop, which means it definitely needs to be cleaned up because it has a box. Node has a box inside it by virtue of having a link that has a box inside it. So we need to, like, the code it's going to generate is going to look at the first element and be like, okay, I need to drop this. But before I can drop this, I need to drop everything it points to. So I need to look over here. So I need to look over here. And that's how the stack grows. I think I confused myself more than anything. I hope that helped in the end, that not the confusion, but I hope it helps to really realize the reason is this node is the owning type that is tricky to drop. Is everyone following? Ish.
I zoned out.
Okay, sorry.
No, it's okay.
So yeah,
it's not your fault.
no, understood.
Yeah.
I was going really fast and making a silly mistake, but the point is, this is the actual recursive bit. Like, this is the core of it. And we need to drop this node. We need, like, actual code does run here because the node owns the other nodes. So we need to, like, the code that it's going to generate is going to free the last node first because it's going to visit the nodes in order. That makes sense. And it's going to look at them and think, how can I free this up? Well, before I free this up, I need to free everything it points to. Yeah. Okay. I might draw something for that next time as a warm-up because that'll be good. But if not, then not. So the simple way is our code is going to do it in the other order. Our code is going to completely free this node before freeing the next node and do so iteratively. And she introduces a couple of things here. So there's no real way to write this code without this. We have to replace the head with empty initially. So first, what do? We implement, the way you implement a trait is you implement drop for list. I don't think you write the public because that's determined by the definition of drop. That takes mutable reference to self. So we have to take something out of our list, which will be by doing std_mem replace ampermute self.head with.
Go back to lounge.
Okay, see ya. And then we're going to use this while loop to iteratively go through. She's using a while loop because, like, we don't have a count, so a for loop doesn't really make sense. But specifically, we're using a while let loop. This is a tricky little bit of syntactic sugar, which is basically like it loops until a certain pattern doesn't match. So this is like the thing that you could write on the left-hand side of a match arm, I think they call it, on the left-hand side of this thing, like to the left of this thing. So, sort of a weird intuition is that these variables themselves are patterns. Like every time we do let something, we could put any pattern there that always matches. Very few patterns always match, but variables do. Because we're just saying you have a thing, don't like destructure it, just put it in this variable. But some variables do, some patterns only match sometimes. That's why we wrote these match statements that have multiple arms. So what you can do here is while the list still has elements, I think, so we do that, but importantly, I didn't mention the list yet. I need to mention the list. What did we, oh, cur link is a better word for first. It's first here, but then we will change it. So I'm going to use my editor's fancy rename everything. That's really enabled by the Rust Analyzer tool. Rename this variable everywhere. So while this current link is more than just why do we, yeah, then replace its next with nothing. So it doesn't point to the rest of the list. Oops. And this is a problem for some reason. Oh, right. I'm trying to replace the current link, which is not okay because if I try to replace the current link, then I'm not entirely sure why this isn't okay. Okay, no, I think it's because this line, trying to replace the current link, no, it shouldn't destroy the list. What does it do? What is the type of this? It's a box. I think the best thing that this will do is just call the normal destructor code. But I'm not sure what's going on here. Borrow of partially moved value. Current link. Partial move occurs because the value has type box of node. When do we move out of current link though? Create it here, that's fine. And then partial move occurs. Okay, so I guess we're moving. Oh, right. We're moving out of current link in this place, which is, like I was saying, this is just like in a match statement. So this effectively moves the box outside of current link, moves its next out of current link. So we can't just replace that. We need to replace its next. No, it doesn't have a next. No, we need to replace next. Right. And now we have a problem because we found a box of a node. Okay. Now we have a problem. Right. No, what? Okay. I'm not quite clear. I don't think I'm going to be able to get to this understanding. I should have prepped more, but this works.
I could use another week to read it, to take away
Yeah.
from reading before.
Okay.
Even if you nailed it.
Yeah, but
I wouldn't mind having some more time to kind of play.
yeah, I will. I think I got a little ahead of myself. We will look at this again. at least we got through, pop and testing.
Yeah, and I'm actually
And
glad
that
the testing
worked.
was there, you know.
Yeah. Was there anything else I wanted to say? Not really. So I guess that's it.
We'll take another look.
And yeah, I will actually leave it like this because that was the.
Sounds good.
And of course, that link that I posted in the Discord, I think right now it's pointing to slightly too far ahead, but as of now, it'll be pointing, as of soon, it'll be pointing to the drop. So you can just, if you want, bookmark that link or whatever, it'll always go to the right point in
That
the
was
in the
really
book.
helpful. Helpful. Good. Thanks. Yeah, that helped.
And yeah,
Otherwise, I would not have looked at it before.
sure.
Cool, thank you.